February 2027, East China Sea. Two F-22 Raptors, the most expensive stealth fighters America ever built, are cruising at 40,000 feet. They own the sky, or so they think. Then the warning system screams, "Missile lock." But that's impossible. They're invisible, the radar cross-section of a steel marble. Nothing should see them, let alone track them. Yet somewhere out there, a Chinese J-16 has them painted on his radar, and his finger is hovering over the trigger. This is the jet China calls the Red Eagle, and it was built to do one thing Western analysts once thought nearly impossible: hunt stealth aircraft. Right now, over 350 of them patrol Chinese skies, making the J-16 the most widely deployed heavyweight fighter of any single air force globally since the early 2000s. Not just numbers, not just hype. This jet carries advanced radar systems that find targets most radars can't, long-range missiles that strike from over 200 kilometers away, and an electronic warfare variant that Chinese engineers claim matches anything the United States has built. But here's what you need to understand first. Stealth technology doesn't render an aircraft invisible. It merely reduces the range and frequency bands at which it can be detected. And China spent the last 2 decades figuring out how to exploit that gap. Go back to the early 2000s. China's Air Force had a problem. The backbone of their fleet? Russian. Su-27 flankers with Russian engines, Russian avionics, Russian limitations. They couldn't fully control their own military destiny. They needed something different, something entirely theirs. Development of the J-16 kicked off as an ambitious project to create a truly indigenous multi-role fighter. Engineers at Shenyang Aircraft Corporation took the Su-30 MKK airframe as their starting point, but what they built on top of it was entirely Chinese-made, from the avionics down to the weapon systems. First flight, October 2011. Service entry, 2013, with the People's Liberation Army Air Force. Then came the evolution. December 18th, 2015, a new variant roared into the sky for the first time. The J-16D, codenamed Roaring Wolf. This wasn't just a fighter anymore. This was a dedicated electronic warfare aircraft designed to blind enemy radar systems and tear holes in air defense networks. The D designation comes from the Chinese word dianxi, which means electronic. That tells you everything about what this variant was built to do. Production scaled remarkably fast. By August 2024, they'd reached the 13th batch, with each batch containing between 24 and 30 aircraft. Total fleet? Over 350 J-16s in Chinese colors. The numbers speak to one of the most successful fighter programs of the 21st century. When a J-16 appears on the horizon, you're looking at a big aircraft. 21.9 meters long, 14.7 meter wingspan. Same ballpark as the American F-15E Strike Eagle. And that comparison isn't accidental, since Western analysts consider the F-15E the closest equivalent to what the J-16 actually does. Empty weight, 17,700 kilograms. Fully loaded for combat, 35,000 kilograms. Over 77,000 pounds of aircraft, fuel, and weapons, all screaming through the sky together. Speaking of weapons, this jet carries 12,000 kilograms of ordnance, which works out to over 26,000 pounds of missiles, bombs, and other instruments hanging from its hardpoints. Power comes from 2 Shenyang WS-10B Taihang afterburning turbofans, each producing 135 kilonewtons of thrust with afterburner engaged, roughly 30,000 pounds of force pushing the aircraft forward. What makes this engine particularly important? It represents China's move away from Russian power plants, since the Taihang is entirely indigenous Chinese technology. Top speed, Mach 2, possibly Mach 2.2, translating to around 2,120 kilometers per hour. Service ceiling, 17,300 meters, over 56,000 feet. Climb rate, 230 meters per second. This jet goes up fast. Range becomes strategically interesting. Without external fuel tanks, the J-16 operates over 1,500 kilometers from base, but add external tanks and that stretches to 3,000 kilometers, with a ferry range that hits 4,000 kilometers. Engineer Ai Zheqiang from Avica's Shenyang Aircraft Design and Research Institute highlighted how the airframe incorporates large strake wing body integration, a conventional twin vertical tail layout, and clipped tip tail fins, all contributing to enhanced aerodynamic performance. These design elements give the J-16 exceptional maneuverability for its size. But raw performance isn't what makes the J-16 special. If you stand with innovation over hype, type Red Eagle in the comments below. Inside the nose sits an active electronically scanned array radar, AESA for short. This isn't a system your grandfather would recognize. AESA technology uses thousands of tiny transmit-receive modules that steer radar beams electronically without any moving parts. And it can track multiple targets at once while switching frequencies rapidly to avoid jamming. The capability to detect stealth aircraft is where this radar separates itself from everything else. It can find fighter-sized targets with a radar cross-section of about 1 square meter at ranges between 200 and 250 kilometers, and it tracks 15 to 20 air targets simultaneously, while keeping the ability to engage multiple threats. But the real advantage comes from low-frequency operation. See, stealth aircraft like the F-22 Raptor and F-35 Lightning are optimized to reduce their radar cross-section against higher frequency bands, where most fighter radars and air defense systems traditionally operate. Physics works both ways though. Lower frequency radar waves are harder to absorb and deflect, even for stealth aircraft. The J-16's radar can operate in these low frequency modes and exploit this gap in the stealth design. Combined with ground-based systems like the JY-27A long wavelength radar, which can detect targets with a radar cross-section as small as 0.001 square meters at distances beyond 400 kilometers. The J-16 becomes part of a networked detection system specifically engineered for finding stealth aircraft. This network-centric approach is what matters most. J-16 formations integrate directly with China's airborne early warning aircraft, the KJ-2000 and KJ-500, which means real-time sensor fusion allows formations to share radar tracks and target information seamlessly across vast distances. China is pushing this even further with artificial intelligence-assisted decision-making tools designed to shorten the sensor-to-shooter cycle and provide predictive threat assessments and missile queuing data within seconds. The jet itself incorporates features to reduce its own radar signature, so composite materials and radar-absorbent coatings help lower visibility on enemy screens. Redesigned diverterless supersonic intakes and an improved internal electronic warfare architecture all contribute to survivability in contested airspace. Let's simulate. It's 2026, South China Sea. Tensions have boiled over. A US carrier strike group operates 300 kilometers east of the Paracel Islands. 4 F-35Cs launch for a reconnaissance sweep. They're confident. Stealth means safety, or so they thought. From Woody Island, 6 J-16s scramble. Their AESA radars power up in low-frequency mode, sweeping the sky. The American F-35s appear as faint contacts at 220 kilometers. Not invisible, just harder to see, but seen nonetheless. The J-16 lead calls back to a KJ-500 airborne early warning aircraft orbiting 150 kilometers behind Chinese lines. Sensor fusion begins. The KJ-500 correlates data from ground-based JY-27A radars, satellite feeds from Beidou, and the J-16 formation's onboard radars. Within 18 seconds, AI-assisted targeting cues flash across the J-16 pilot's helmet-mounted displays. Target locks achieved. Each J-16 carries 8 PL-15 missiles. Developed by the China Airborne Missile Academy, the PL-15 represents China's most advanced beyond visual range air-to-air missile, and the specifications should concern anyone who thought stealth meant safety. Domestic variants can engage targets between 200 and 300 kilometers away. Speed approaches Mach 4 to Mach 5 or beyond. At those velocities, even aircraft with advanced warning systems have precious little time to react before impact. The J-16 lead fires first. The PL-15 drops from its hardpoint, and the first pulse of the dual-pulse solid-fuel rocket motor ignites. The missile accelerates towards the F-35 formation at over 5,000 kilometers per hour. Guidance combines inertial navigation during the initial flight phase with mid-course updates via two-way data link and China's Beidou satellite system. When the missile gets close, an AESA radar seeker takes over for terminal guidance. That AESA seeker provides high resistance to electronic jamming, the same jamming that older missiles could be spoofed by. so the seeker continues tracking targets even through countermeasures that would blind previous generation weapons. The American pilots detect the launch at 180 kilometers. They break formation, fire chaff, activate electronic countermeasures. But the PL-15 isn't fooled. At 15 kilometers, the second pulse ignites. Additional energy floods the terminal phase, right when the missile needs it most, as it's closing on a maneuvering target. This design dramatically increases kill probability, even against the most agile aircraft trying to evade. The warhead is high explosive fragmentation design, weighing between 20 and 25 kilograms, and triggered by laser proximity fuse or active radar proximity fuse. It doesn't need a direct hit to kill. 3 seconds later, impact. The lead F-35 disintegrates. The second takes shrapnel through the engine. It tumbles into the sea. The remaining F-35s disengage. They run, but the J-16s don't pursue. They've made their point. The American carriers pull back 200 kilometers. The balance of power in the South China Sea shifts in one engagement. Welcome to the future. If the standard J-16 is the sword, the J-16D Roaring Wolf functions as both shield and hammer. Chinese engineers designed this variant to match or exceed the capabilities of the US Navy's EA-18G Growler. Given what the Growler can do, that's an ambitious claim. But the specifications back up the ambition. The J-16D carries 2 to 3 external jamming pods under its wings and fuselage, each optimized for different radar frequencies. Frequency coverage spans from 0.05 to 20 gigahertz, essentially the entire spectrum used by modern military radars. Power output becomes remarkable here. Previous Chinese jamming systems operated in the 30 to 40 kilowatt range, but the J-16D systems approach 100 kilowatts. That increase in transmission power extends the effective jamming distance from tens of kilometers to more than 150 kilometers. The J-16D can blind enemy radar networks before friendly aircraft even enter the threat zone. The electronic warfare suite can analyze incoming radar frequencies and determine the precise location of radar transmitting equipment, which enables both targeted jamming and kinetic attacks using anti-radiation missiles like the Eagle Strike 91 and newer systems China has developed since then. Chinese sources describe the reconnaissance warning system as the most advanced in the world at this stage, claiming that only China and the United States have independent development capability for this technology. Beyond radar jamming, the J-16D carries tactical communication jamming systems capable of deceiving, jamming, and suppressing land-based, sea-based, and air-based communication systems and data links. In modern networked warfare, cutting communications can be as effective as shooting down aircraft. Electronic warfare arrays are built directly into the fuselage as conformal installations, which reduces drag and increases combat performance compared to older designs that relied entirely on external pods. February 2025 brought J-16 deployments to the Sisha Island chain in the South China Sea, known internationally as the Paracel Islands. These deployments transformed contested islands into what analysts call unsinkable carriers, which reduces China's need for aircraft carriers while maintaining persistent air power projection in disputed waters. From forward positions on these islands, J-16 can enforce air defense identification zones and project power far beyond the Chinese mainland, directly into areas contested by Vietnam, the Philippines, Malaysia, Brunei, and Taiwan. Vietnam contests China's control over the Paracel Islands, and that adds another layer of tension to an already volatile region. Then came October 2025. Chinese state media released a CCTV documentary claiming a PLAAF J-16 pilot had intercepted, locked onto, and forced 2 US F-22 Raptors to retreat over the East China Sea. If accurate, this would represent proof that China's anti-stealth capabilities have matured to operational effectiveness. Western experts remain skeptical, with some calling it propaganda, and considering such an encounter highly improbable given the F-22's capabilities. But here's what matters. Whether that specific incident happened exactly as described or not, the technology to make it possible exists. Ground-based radars, networked sensor fusion, low-frequency detection systems, long-range missiles, all of it is real, and China is actively training for exactly these scenarios. Major exercises like Red Sword and Golden Helmet have PLAF pilots simulating engagements against stealth and electronic warfare threats, refining real-time data fusion and multi-domain coordination with each flight. The future may include even more exotic technologies. Chinese defense institutes are developing quantum radar that could theoretically detect stealth aircraft by measuring changes in photon states. They're investing in plasma stealth technology, directed energy weapons, airborne lasers, and high-power microwave systems designed to disable enemy sensors and missiles. Stealth changed air combat when the F-117 flew into Baghdad in 1991. Nothing stays revolutionary forever, though. The J-16 represents China's bet that the stealth era has an expiration date. The question isn't whether stealth aircraft can be detected under the right conditions. We know they can. The question is whether the J-16 and its supporting systems have shifted those conditions permanently. And that's something only the next conflict will answer.